Hello everyone, my name is Masha. I'm the Quantitative Study Advisor at LSE Live. This recording is for the ACO Quantitative Exams Workshop. There are currently two versions of it, one that runs in winter term and one that runs in spring term. In this specific recording you will find examples for both, which are denoted by either words winter and spring or by letters W and S. So use whichever examples you find most helpful, and please feel free to come and see me in quantitative advice if you need some more personalized advice and more help. Today we're going to talk about some general tips on how to plan your time, how to prepare revision notes that are going to help you in the long run, how to work with quantitative models, what to do if specific issues arise, and some final tips for your exam preparation. Step 1. Plan your time. At this stage, it is important to list down all your quantitative courses. We're going to work on a comprehensive revision schedule that is tailored to you. How you would typically go about it is to go to the course outline or the syllabus, list all the models, topics that were discussed in the course, and while you're doing that, please keep in mind it's not necessary to have one lecture week to correspond to one topic. Sometimes you might have a more complicated topic which is covered over a couple of weeks. In other cases, maybe you have a couple of topics per week, so just make the schedule comfortable to you. Then, next to each of the revision topics, you would assess priorities of the revision based on your experience with the specific models. At this stage, you would identify personal favorites and outsiders and think about your strengths and weaknesses, which of the topic would require extra attention from you and which are generally more fine. Some general tips which are no less important than subject-specific advice is to make sure you have plenty of time for your revision. There are some useful tips and handouts in another workshop from LSE Live, which is called Plan Your Winter Break, Revision, Writing and Research. So make sure you'll check it out. Don't forget to have breaks. Breaks are supposed to recharge you, to give you second breath to attempt your revision, so they're really important. And of course, leave at least a couple of days before the exam to digest what you've learned, to unwind, to mentally prepare for the exam. So keep this in mind while you're planning your revision structure. It's always very important to have enough sleep, and I cannot emphasize it enough. Perhaps this is the most important advice I can give you, especially for a quantitative exam, because you would need to be alert and focused just to make sure that your calculations are right, there are no small mistakes that lead to a wrong final answer. You remember each intricate detail of the model, step-by-step solutions. So sleep would be your friend in this case, and please make sure you have enough of it. We're going to do a little practical exercise, no more than 5 minutes, just to get you started on your revision schedule. There is a revision schedule handout, which you can find on LSE Live Moodle page under this specific workshop. For this exercise, I would ask you to pick one quantitative module, to go through the syllabus, the course outline, and identify the list of topics to work on. Make sure each topic corresponds to a model, a concept. It shouldn't be too broad, but it also shouldn't be too narrow. You need to find a perfect balance of what is easiest for you to study, and next to each topic you would assess your confidence level. A tip: you can always bring your revision schedule study plan to me in quantitative advice, and we can go through that together. Now I'm going to show you some examples of several quantitative modules, but please remember they are not representative of what your revision schedule should look like. These are just some brief illustrations, and they must be treated as such, even if you take the courses I mentioned yourself. You can apply the technique to your specific course content, personalize it according to your learning objectives and study style preferences. Our first example comes from EC1A3, So this is a microeconomics module, and I just listed a couple of topics which I think would constitute a good revision topic. So the first one would be model of rationality, and you would ask yourself, while you're doing the revision, why we need a specific model, what's the structure of this specific model, more on that later. And then there are consumer side of the story, firm side of the story. This could be your two subtopics. Once again, we've made it as fine as possible to ensure effective revision. You don't want to focus on both sides simultaneously. You would split it into two parts, consumer and firm, and make sure that you understand it. Another topic that we could use would be labor market, and again there are two sides of the story, model of labor demand and model of labor supply. Just some idea for you on how to structure it. And then you would work through each of the models and note down both theoretical information and examples from problem sets and past exams. Another example comes from EC2C3, so this is an econometrics module. Some topics that I included are bivariate regression, ANOVA, instrumental variables, etc., etc. So you would typically refine the subsections as is best for your understanding, and keep in mind these helpful questions. Where do we use a specific model? What type of notation we use? What's the meaning behind the coefficients? Make sure you work both through theory and examples. But we'll talk about the model approach soon enough. And example with MA 107, perhaps one topic could be recurrence equations, another can be partial differentiation, listing down rules, meaning of each of the rules, examples, chain rule, again rules, meaning and examples, etc. Another example would be EC1B3 from spring exams, and good topics to identify here would be solo growth model. So in the syllabus you can see that there are several models under the umbrella of economy in the long run. So the deeper you go into it, the better. So solo would be one option. The next model that you can talk about is Roma growth model, and perhaps at this stage compare the two between each other. Another good topic for revision is labor market or unemployment. You would have to work through each of the models using the technique I'm going to show you later, and work through both theory and examples. Another example would be revision for MG205, and this is an econometrics course. One subtopic that you could focus on could be hypothesis testing. If you take a look at the syllabus, you notice topic experiments. This is quite a large topic, and you can further narrow it down. For example, pick external validity. Another good topic for revision would be instrumental variable regressions, but again, you can personalize it as much as you want. Just go deep into the topic as much as you want, or make it broader according to your learning practices. And final example for today is MG207. So this is managerial economics. There are three main aggregates of topics: consumer theory, producer theory, market level analysis, and then within this huge branches you could identify subtopics that you can work with. For example, in consumer theory it could be Slutsky equation, in producer theory profit maximization, cost minimization would be another one, market level analysis. There are various models there. I picked Bertrand competition as an example right here. Now let's talk in more depth of what revision notes would look like. Ideally, you would start to prepare revision notes weekly from the beginning of the semester, but don't worry if you haven't done so yet. You can still implement the strategy now. Just focus on the priorities, and this is why we've identified them in the first step, planning our revision schedule. But please don't try to do everything everywhere all at once. Once again, at this stage, if you haven't started implementing the strategy yet, it will be helpful to implement it on the most difficult topics first. Keep in mind that you need to think about the link between theoretical information and practical examples. More about it soon. Don't despair if you don't see the connection first, but always keep the bigger picture in mind. What is your specialization? How will this course help you with your specialization? For example, if you are a student from geography and you're taking an econometrics course, obviously you're using econometrics as a tool, and you're not going to be an econometrician or statistician at the end. You're going to be studying geography. Econometrics helps you with some aspects of that. Another important advice for your revision notes is to write them down, paraphrasing as much as possible. Copy-pasting slides on the computer, or simply copying information is just a waste of time. Make sure that you understand every sentence that you put in your revision notes, and this will also serve as a red flag strategy for you. So whenever you write something down and you understand that there is no way you're going to remember it unless you learn it by heart, it means that is a red flag. You would need to have more understanding of what you're doing, to work a little bit more on that specific definition or formula or model in order to understand it. Coming back to emphasizing the link between theory and practice. Don't forget that lectures provide you with a theoretical background. You can treat it as the foundation or the bricks. Then you apply this foundation to the problem sets and past exams. So while you're preparing your revision notes and you're writing down theoretical concepts for a certain topic, make sure that you follow them with examples from problem sets, weekly exercises, lectures, and past exams. Also, it is helpful to think about how you can tweak a question, maybe change one little assumption, and see how the model changes. This is a good practice to have because most of the past exams you would see are variation of very similar questions. So this gets you into a habit of thinking about how one change in a model can change the question and what you would do in order to solve it. Past exams are an invaluable source of practice. They're available on LSE Library website. Please follow the link. No matter how many past exams you have for your specific course, I would advise you to keep at least a couple aside so that you can practice with a timer, especially if this is the first time you're taking an exam in a university setting. You would replicate exam conditions, make sure that you're somewhere quiet with no disturbances, and you don't have access to your materials if your exam will be closed book. So just mimic the exam conditions as closely as possible. Once you practiced with mock exams, use questions from them to add to your examples in revision notes to illustrate your theoretical models. While you're doing that, identify your strengths and weaknesses and pay extra attention to them while revising the material. I promised to give you specific advice on how to work with quantitative models, and this is what we're going to do in step 3. Sometimes you may think that the models are presented in the lecture slides a little bit in a confusing manner, so they would jump between different assumptions and then examples back and forth. So it is the job of the student to work on different components of the model, understand how they figure into a bigger picture. So that's why we're using the approach of disassembling the model into blocks and reassembling it back together. This pyramid will help you with the majority of quantitative models. You start from bottom and work all the way up. The foundation of our model are assumptions and variables. Assumptions are the rules of the world in your model. Once you understand what assumptions and variables you have, you can proceed to building relation setup. This will be cementing it all together. It will show you the relations between different variables in your model. After that step is complete, you can assemble the final model, solving it step by step, and then whatever additional information you have, for example graphs, will follow in the very last box. Small exercise for you to do, again no more than 5 minutes. Pick one of your quantitative courses and any model from that course. Prepare the model structure. For that, you can use the model structure handout, which is available on LSE Live Moodle webpage. Then you would work on the structure, just as we discussed, assumptions and variables, then relation setup, then building the final model, and providing whatever supplementary material like graphs you have. Another little disclaimer. Following examples are not representative of what your models should look like, even if you're taking the courses yourself and studying these models currently. They should be treated just as they are, as a brief illustration. I basically gave a couple of examples for each of the boxes in these models, but they're not complete. You can apply the technique to your specific models and personalize it according to your learning objectives and study style preferences. And of course, it's very important that you use notation from your specific module, because notation will vary from lecturer to lecturer, textbook to textbook. So always prioritize the notation that is used by your lecturer. The first example again comes from EC1A3, and this is consumer optimization problem. Some very basic assumptions, rules of the world, are rationality. We assume that agents are making rational choices, because otherwise we would not be looking to maximize utility. So that's a very important rule of the world for us. Preferences, complete, transitive, etc. you would know best. Then some assumptions on the budget constraint, prices, goods, etc., etc. Some variables would be quantities. They're denoted as x1, x2 on this specific slide, but it could also be q1, q2, many other forms of notation. Income here is denoted as m. After you're done with listing the variables, we move on to relation setup. Here I have a Cobb-Douglas form of the utility function. So u of x1, x2 is equal to x1 to the power alpha times x2 to the power beta. It can be another form of the utility function depending on your question. So this is where you would already ask yourself, what would change if I change the utility function, right? Imagine you're writing it as x1 plus x2. What changes in your final solution? Then, second point in the relation setup is budget constraint. P1x1 plus P2x2 is equal to m. And you can think of some more relation setup for this specific model. Then in the final model box, you're solving it step by step, whichever way your lecturer explained you to solve it. So EC1A3, here we're writing up the Lagrangian, but you might not have solved it via the Lagrangian, just prioritize the way that the lecturer solved in the slides. You can take some first order conditions and find the optimal quantities of x1 and x2 that maximize the utility. And then in the graphs or other supplementary material, you can, for example, draw a budget constraint and several indifference curves and show the optimal consumption bundle. This is just one idea. The next example is from EC2C3, and this is the instrumental variable regression. Some very important assumptions for this type of regression: endogeneity, where covariance between x and u is not equal to 0. Instrument validity. This could be relevance, covariance between z and x not equal to 0. Endogeneity, covariance between z and u is equal to 0, etc. Again, these are rules of your world. Variables would be dependent variable y, endogenous regressor x, however many you have, instrument z, error term u, etc. Relation setup could be structural equation, first stage equation, second stage equation, then however you need to solve it, estimate coefficients, perform whatever tests you need. For example, in this case for weak instruments or over-identification, and then whatever supplementary material you can offer, for example, graphical representation of endogeneity, scatter plots, regression line, etc. An example from spring exams would be EC1B3, macroeconomics, so solo growth model that we've previously mentioned. You again can split it following the framework that I showed you. So assumptions, again, ask yourself why each assumption is important. Endogenous capital stock, constant returns to scale, in capital labor. Ask yourself, how does the problem change if you break the assumption? What if there are increasing returns to scale or decreasing returns to scale? The next assumption is diminishing marginal product of capital and labor. So again, it would be helpful to think carefully why this assumption is important, why this rule of the world is important for your model. Variables, again, capital, labor, obvious choices, but you can also include some notation here that is important for you to remember. Relation setup will be the setup between the set variables. So, for example, production function, and we again have a very common Cobb-Douglas production function. At this stage, you can also ask yourself, what happens if there is another type of production function? Maybe it's just one input, k, for example, yt is equal to kt. What happens then? How your how your solution changes. Resource constraint, so here you have consumption and investment, capital accumulation equation, etc. So whatever describes the relationship between your variables will fall under here. And then in the final module, you will solve it step by step, following the instructions from your lecturer. So I have a small suggestion here. That's again following the slides from EC1B3. So make sure you carefully work through the final model step by step. You understand where each step is coming from. And then graphs and other supplementary information will enhance your understanding of the topic and will help you answer exam questions in a clearer way whenever you need to use this specific model. And again, an example with optimization from MA 107. Assumptions that we make here is that we have a continuous differentiable function, otherwise the optimization wouldn't work. We assume that there are stationary points, and any other assumptions you would think of. Variables are, for example, x, independent variable, and the function that we study, f of x. Relation setup would be first order and second order conditions, and then in final model, whatever the purpose of your model is, that is what you would solve here. For example, profit maximization, asset valuation. You would compute the first order derivative and solve it to find critical points, use second derivative tests, etc. And then graphs and other information would be, for example, sketching critical points or plotting profit function. Again, depends on which type of question you're solving. Now, what happens if you get stuck or if any issues arise? If you feel that you're getting overwhelmed by the material, it's important that you take a break. This is not a waste of time, but it is in fact an investment into your energy. It can be a coffee break with a friend or a brisk walk, whatever helps you. Also, if you get stuck with a certain question, you can switch to something else. Maybe, again, a nice break, reading a book, or you can actually switch to another course if you don't feel like wasting time with your revision. Sometimes we just need to get a fresh perspective, and switching to another course or a book can give you that perspective. If no matter what you do, you feel like you're still stuck, please see the next slide for advice. If you're still stuck, this is what I would call meeting a formidable foe in a form of a model or a concept. There are several ways around it. I would first advise you to go slowly, step by step, and identify the exact place where the question arises and try to answer why. Maybe there is an intermediate equation that was skipped, maybe a no notation that you need to work a little bit more on, or maybe that particular step builds on basic math or stats concept that you studied a long time ago and just need to brush up on. Once you can describe the main issue, you can devise a strategy. For example, work through the equation with pen and paper to identify that intermediate equation skipped. Split it into finer pieces and blocks, and revise the specific concept that you've studied once upon a time and that prevents you from solving this model. There is no one right strategy that conquers all. Inevitably, it would be a trial and error situation, so please don't lose confidence. It's all part of learning. If you're still struggling to address the particular question, help is always available here at LSE. Your first point of contact would be, of course, your lecturers. They're always there to help you and answer your questions in the office hours, so please make sure that you reach out to them. You can also drop them a quick email. Another very good resource is studying with peers in study groups, because the more brains are working on a problem, the better it is. If you have a specific mathematical questions, you can reach out to math support. If there are software questions, please make sure you see what support is available at Digital Skills Lab. Links are provided on the slides. Then there are always Econ and Stats Lab for specific courses. They are located on the ground floor of the library in Workspace 3 and are organized in a form of drop-in sessions. Please feel free to come to me for advice with any quantitative questions that you might have. You can book quantitative study advice following the link on the slides, and I will try to help you as much as I can myself, but even if I cannot help you with your question directly, I'll still be able to guide you towards help. So it's always worth booking a chat. We're all here to support you and address your concerns. It's important that you understand what question you need to ask. For example, a general question like explain chapter 7 would not be a good one, but in case you need my help to formulate a specific question, also make sure you see me in quantitative study advice. If something prevents you from taking the exam, please contact your departmental senior student advice team as soon as possible. They will help you figure out what to do, but just make sure that you let them know as soon as possible. Some final exam tips from me. Make sure you know the format of the answer the lecturer expects from you. This is actually a good question to ask during the lecture or in the office hours. Perhaps they expect more mathematical steps, step-by-step explanations. Just make sure that you ask that question in advance before the exam. Again, I cannot emphasize it enough. Please do get enough sleep before the exam, especially before the quantitative exam. And you got this, everything will be fine. Thank you for listening to this workshop. Good luck with your exams.